calculus. The last video for lesson 7.4 is going to cover the area of surface of revolution. So prior to this lesson, we did volume of revolution, and this formula for surface area is going to allow you to find the surface area of your three-dimensional figure that you're revolving, or that is the result of revolving your shape around an axis. If you're interested in where these formulas come from, down here I have referenced you to page 482 in the textbook. So you're using this the lateral surface area of a right circular cone to derive these formulas. So if you're interested, the book goes through the explanation and it provides some nice graphics to kind of show you what we're doing. You guys that are taking the final are going to have these formulas memorized as well. It looks like arc length, but there's a couple differences. 2 pi has been added to the outside. It has to do with circumference. And then you have the radius added in right there. So 2 pi and the original function are now included in the formula. You'll see that the work, though, is very similar. We're going to just do this one example. I think you'll catch on with just one example. So we're going to take x to the third, revolve it around the x-axis from 0 to 1. So I'm not finding volume, I'm finding the surface area of the resulting shape. All right, so the formula now uses a capital S for surface area. It goes from, with 2 pi on the outside, a to b, f of x, so the original function, and then it's going to be 1 minus f, or 1 plus f prime of x squared underneath there. Now, the radius here is going to be the length of your rectangle. So if you go back to what we did with volume, this guy is coming through here. I'm going from 0 to 1. So it's this shape right here that you're revolving around the x-axis. That original rectangle is going to be this r of x, which in our case is the original function. So that's why I just swapped it out with f of x, because that is actually x to the third. All right, to get you going here, I'm going to do what I did last time on the previous two examples. I'm going to start with f prime of x, and that's just 3x squared. Then I'm going to go ahead and square that. And then the third step is to add 1 to that. All right, fair enough. I think you've got that mastered. So what we're going to do from here is plug that in under the radical. And we're going to put the original function there on the outside. So switch gears, switch colors, 2 pi, 0 to 1, x to the third, square root of 9x to the fourth plus 1. We'll do a little bit of substitution. We're going to let our u be 9x to the fourth plus 1. Our du is 36x to the third dx. I already have the x to the third, so I'm going to be popping in a 1 over 36. Like I did before, I'm just going to do u substitution here on my integration as well. So my bounds of 0 and 1 are going to change again. So I'll be putting in my 0 and my 1 right in here for x. So plugging in 0, I'll get 1, and plugging in 1, I'll get 10. So pi over 27, 10 to the 3 halves minus 1 to the 3 halves. All right, and that, you guys, is about 3.563. Okay, again, taking a look at your practice problems. I want to see your integration by hand. I think that's going to help you prepare for the final. Until you get to, let's see, there is one of them, number 9. That one's a little bit messy, so I'm going to let you use a graphing calculator to do the integration for that problem. But other than that, all your work should be there. These will take a little while, so don't try to sit and do the homework all in one setting. Today is Monday, so you've got a few days to get this done. So pace yourself, get frustrated, stop, put it away, bring it back out, and we'll go from there.